So hi everyone, 30 seconds past top of the hour. My name is Eric Tran Lee. I will be your host with Wendy Zui for today's session on fighting faster payment fraud with machine learning. Let's do a quick introduction of ourselves, Wendy. Why don't you start?
Sure. Thanks, Eric. My name is Wendy. I'm the Director of Product Management here at Guardian Analytics.
And I'm Eric Tran Lee. I'm the Head of Product Management. Let's do some quick housekeeping. Today's session is being recorded. You will receive a URL link notification if you want to watch later this session or send it to your colleagues interested in faster payment fraud detection with machine learning. The presentation slides are in attachment as well as some public sources that we are going to refer to during the webinar. We do recommend that you have only one BrightTalk session browser open, otherwise you may have some echo. And if you have any question today, there is a question box where you can enter them. We will address them either live and or by email. Last but not least, please rate and suggest us content to improve our webinar. Let me go forward and read quickly the safe harbor. The following is intended to outline our general product direction. It is intended for information purposes only and may not be incorporated into any contract. It is not a commitment to deliver any material code or functionality and should not be relied upon in making purchasing decisions. The development, release, and timing of any features or functionality described for Guardian Analytics product remains at the sole discretion of Guardian Analytics. With that, what does Guardian Analytics do? First off, we are truly machine learning and behavioral analytics first and foremost. Like a lot of people will be mobile first, we are truly machine learning and behavioral analytics first and foremost for fraud detection. The core principles are that we have self-learning capability in the risk engine, so it learns the individual user behavior, and we do not depend on static rules. We monitor all the user events in real time, and we detect anomalies with the highest accuracy rate with the lowest false positive. Now, to introduce the topic of faster payment, one should be reminded of that the Federal Reserve, in his final report, part 2, that we have attached a link to an attachment called a call to action, has set the goal for faster payment ubiquity by 2020. The goal, say, strategist leader San Rodriguez, is to have a shiny new payment system that would deliver broad benefits to American consumers and businesses by delivering real-time, data-rich payment by 2020. Now, what does it mean? If you look at the spectrum of what we have today in the U.S., from faster payment on ACH delivered by NACHA to Zelle, but also, push card risk, you can see there's a vast spectrum of speed of payment there. And the expected faster payment market, according to market research, was about $225 billion in 2018. It's probably too soon right now in 2019 to understand really what it is about, but it covers a couple of use cases. One is the business-to-business faster payment, consumer-to-business, and person-to-person. And the total U.S. payment volume is projected to be 88%. Now, what does it mean? Well, faster payment in the U.S. is pretty much analogical to what happened in UK. UK actually went into faster payment in 2008, so probably a decade now, a little bit more. And you can learn a lot from it. In UK back in 2008, the initial design was to offer a 2-hour window so that the participant banks could carry out relevant risk checking before delivering the faster payment. And it did evolve into faster real-time payments. And there are two broad segments. If you look at the speed of payment, you could categorize them into immediate real-time payments or same-day payments. So in our case, if you look at in the U.S., same-day payment, which means if you look at would be about hours, would be everything on same-day ACH, for example, and fastest ACH. As you move up towards minutes and seconds, you would have push-to-card payment, Zelle, but also the clearinghouse RTP. And this is basically the continuum of what we have in the U.S., which pretty much is analogical to what UK started in 2008. Now, where the real changes are, and unfortunately, very few people talks about is what does it mean? What is the impact on the operation, the fraud team operation or money laundering operation? What you can see here is where you're moving from business hours, intraday business hours, to 24/7, 365, which is almost like a follow-the-sun approach, which is really, really different in terms of processes and organization. And therefore, moving to faster payment is not about just technology, it's also about reengineering the processes. Faster payment means faster fraud. Well, no later than 3 days ago, Forbes have published an article on a data leak bank called Collective One. I don't know if you heard about it. It's about 772 million leaked username and password called Collection Number One. We have attached the Forbes URL as a reference. This is a gigantic database of username and password, and we are not inviting you to check, but personally I did, and it's a little bit scary. So what it says is the first line of defense, which is factor authentication, so on and so forth, has been breached. Most of the fraudsters out there have a very cheap way to get username and password right now. They don't even have to go through social engineering or any sophisticated hack. This is at their fingertips. And what they do, first off, is to do the account takeover. It's almost as skipping the reconnaissance to social engineering and go and compromise your account right away. And what they do is they replace your username and password with synthetic identities. Synthetic identities are fabricated username and password. They're all fake, but they do have a real phone number, real address, so it's very hard to understand if they're fraudulent or not. Once they have synthetic identities, then they could go and exploit faster payment, which is basically going to the speed and efficiency of faster payment and be sure that they can carry out their financial crimes quickly. The fraud review being reduced, they're able to get out with the money very quickly. So what is at risk here? It's basically that because of the acceleration of payment, the rule-based fraud detection are outrun. Now you may ask yourself, look, I hear a lot about this. I'm hearing a lot of AI, machine learning, and a lot of vendors are talking about it. And yeah, right. I mean, you cannot use rule-based detection for faster payment. You will be outrun very quickly. Now, let me tell you how you would know if you are truly machine learning or behavior analytics as opposed to rule-based. You have to go and ask the question to any vendors telling you that their machine learning is, first off, does your fraud detection engine rely on any predefined rules, yes or no? If it is a simple answer. If it's yes, maybe, then I can tell it's a rule engine. Does it learn over time, or do you have to go and ask for consulting to come in and configure your rules? Is it a one-size-fits-all solution where a set of rules has to be tailored to your businesses? And this is important because in the case of machine learning, the machine learning learns your business. So that the machine learning is tailoring itself to your businesses. And therefore, you don't need to go and reconfigure every single time. It's just self-calibrating itself. And of course, the highest the highest type of clue you want to have is the detection rate. How much false positive do you have? In the case of machine learning, we're going for the highest detection rate with the lowest false positive. The single biggest risk is truly about real time. As you go into faster payment, if you are going to be in real-time payment, which is, as you see in the spectrum of faster payment, the fastest you can get. So, you are no more in hours, you're in the second. You have to have the ability to say yes or no in real time. And this is what Donna Turner, Chief Fraud Policy at Zelle, is recommending. What are the risks of inaction? Well, again, a look back at UK decade of faster payment rollout. Well, in the first 2 years, fraud rate has tripled. So this is something we should expect in the US and mitigate. And you can also learn from faster payment that today is being pretty much known by the millennium as being the Venmo. As you can see, even in the case of Venmo, the fraud rate has hit 0.4% of the overall volume in March 2018 after launching instant funds transfer. This is about 40 million operating loss due to fraud. And by the way, Venmo has to put some friction in it, so a friction in the real time so that they can control the fraud in a meaningful way. So what are the key success for faster payment fraud detection? First off, you need to be able to monitor the behavior of a user in its banking account activities and transaction in real time. It's all the events and every single event in real time. You cannot use rule because it will basically detect only a certain range of events, and that is not possible for real time. You have to monitor all the events in real time. Secondly, you have to monitor the behavior and not the conditions. So basically, the machine has to learn what is the pattern of events behavior from that user and detect ever-changing fraud scheme that will alter that pattern. Last but not least, in the case of faster payment that uses mostly digital banking, could be mobile, could be online, there is a notion whereby if you want to detect in real time, you need to be able to do friction right. So what we call friction right is the authentication right now is what we call multi-factor authentication. You have a passcode, they ask you for a username. Well, if you introduce too much friction, then the user will probably not use that payment channel. However, if you do frictionless, then fraudster is going to come in and basically increase the number of fraud. However, if you are using machine learning behavior analytics, you are able to balance a frictionless and friction right, where you introduce a notion of risk-based authentication, whereby you're going to select the multi-factor authentication based on the risk that the customer has at logging time or during his payment activity on his mobile phone, for example. So now I'm going to hand it over to Wendy that will explain to you how Guardian Analytics platform is helping you addressing these challenges. Wendy?
Thank you, Eric. Thank you, Eric. And hello, everyone. So Eric has set the stage of the key success factors for secure, faster payment fraud detection. And in this next section, I'm going to walk you through how Guardian Analytics enable customers to mitigate fraud and implement secure, faster payments. There's three key components that we have that we see as an advantage over other fraud detection tools on the market. The number one is we have advanced machine learning and behavioral analytics that we can lower the false positive and securely lowering the friction for the legitimate payment and detect fraudulent behaviors. Secondly, we have the real-time based risk-based intervention that allow us to transform your fraud operation from loss recovery to loss prevention. And then lastly, in order to support these two capabilities, we have enterprise API integration with Verizon banking platform for real-time account behavior monitoring and allowing the data to flow seamlessly and in real time across banking platform, payment platform to our fraud detection platform. So at our Guardian Analytics, we use multi-dimensional risk models for real-time fraud detections. We evaluate hundreds of data points in real time as we receive those account behavior events. So the algorithm learns about users' device pattern, location pattern, account activity pattern, to name a few key components. Within these dimensions, or within each of these dimensions, like I said, there's hundreds of data attributes are being evaluated to generate the risk score as user events occur. And this is how we can identify fraudulent activities or anomalous activities among legitimate users' activity. So here we want to show you is an illustration of how behavioral analytics at work. So as you can see on the screen, the graph demonstrates each banking user has a very unique behavioral fingerprint. And if we plot it across the board for a subset of these users, you will see they each exhibit different kind of activity patterns. So when we pick, say, just two dimensions, the time and the login activity, and plot these behavioral as a heat map, we can tell that some users have a very unique login pattern versus others. Some, for example, will have a behavior that tends to log in across any time of the week at any time of the day, versus others have very concentrated login behavior that they only log in at a certain day of the week and at a certain time. So this is a kind of a simplified version of telling the story of how behavioral analytics is working behind the scenes. And we use machine learning to learn these individual persons' behavioral history, and like some other system where the user population as a whole were segmented into a finite number of rules. So the anomaly are detected with very nuanced signals, and that's how we're able to reduce false positives. So we believe that reduced fraud loss is the #1 driver for any financial institution to devise their fraud mitigation strategy, right? Lowering the fraud loss and lowering their fraud exposure. And the cost of the fraud loss depends on how fast you can detect the fraud and how many layers of protection you can implement to create hurdles for fraudsters. So if we place the fraud detection services on the market into a quadrant with two measures, on the x-axis, how fast you can detect the fraud, and on the y-axis, the number of layers of protection that you have cross channels, then we can see that the traditional rule-based detection are at the kind of the center of the quadrant. We're putting the financial institution in loss recovery mode by default, right? Because these type of systems are most likely processing transaction that has already occurred and try to identify the fraudster, but if the fraud is identified, the money has already left the bank. Therefore, they're reacting to the fraud that occurred, and then therefore, they're always trying to recover the funds. So by definition or by default, they're always in the loss recovery mode. And there's other type of fraud detection tool on the market where they are capable of screening or monitoring transaction before it's settled or after it's settled. However, they only monitor and identify the fraud among the transactions, but they have no capability to intervene when they detect the fraud. So for these type of system, they're sort of in the middle. They can be seen as proactive monitoring transactional fraud. However, they're still in loss recovery mode because the money has already left the account due to lack of intervention at the moment when fraudulent activity has been identified. So in contrast, where Guardian Analytics can detect and intervene in real time across multiple channels, that we can monitor both the digital banking account activity as well as the transaction processed by the payment platform. We not only can detect fraudulent activity in real time, but we also enable real-time intervention that to either pause the transaction or cancel the transaction. So we're proactive in terms of monitoring the fraud, and we're also allowing the financial institution to prevent loss from happening. And this is how we transform the fraud operation from loss recovery mode to loss prevention mode, and therefore lowering the overall fraud loss or the cost of fraud operation. So how do we actually do the real-time detection intervention? Let me walk you through the process. The fraudster may engage with digital banking or payment platform in this particular example through a variety of channels. They could go to the branch, or they could engage with digital device. And then when they initiate a payment, those payments get sent to the payment platform. And as we have real-time API integration with the payment platform, the transaction or payment details are sent to Guardian Analytics, and we evaluate the risk of these transactions in real time as the events being received. So the customer can also self-configure intervention policies in our system to apply to suspicious behaviors. So for example, they can choose to place a transaction or risky transaction on hold, or command the payment platform to trigger a MFA challenge when the risk is high, or put a threshold and say if the risk level is about certain threshold, I'm just going to cancel this suspicious payment. So these intervention policy can be leveraged to mitigate the risk at real time when a suspicious behavior is being detected, and it can also help to create a window for the fraud analyst to review those payments and then make a manual decision. So as illustrated here, while the risk score or intervention policy being applied in real time back to the payment platform, fraud alerts can be generated in real time and displayed in the application for the fraud analyst to review. And the fraud analyst can do their investigation and come back to those transactions and indicate whether the transaction should be let through or the transaction should be canceled. And with these type of automated intervention plus the additional ability to manually review and cancel or release those payments that may be temporarily put on hold, the fraud analyst can buy themselves a window, apply their investigation, and triage those fraudulent alerts and back to the payment platform. So with that in mind, you may wonder whether any customer has utilized these kind of a real-time detection and intervention in their fraud operation, and the answer is yes. So let's take a look at a real-world example of how Guardian Analytics fraud detection is useful for faster payments in action. Here is an example of one of our large financial institution customer utilizing our fraud detection product across multiple digital banking and payment products. So the customer has engaged with us, and we're using our detection for their consumer as well as business bill pay channels. They have used our product to protect their non-real-time P2P and A2A payments. Non-real-time P2P has been available on the market for some time. They also are working with us and using our wire product to detect wire fraud and utilizing the real-time intervention, configuring the policy so that they can put suspicious wire on hold while the analyst reviewing those wire and then making a manual decision whether to release or cancel those wire. They applied our ACH product to their same-day ACH, which is the fastest ACH available today. They're also working with us actively to implement fraud detection for their real-time P2P, which is provided by Zelle for their retail banking customers. So as you can see, in this setup, in this payment ecosystem, there's many different vendors providing different payment products to the financial institutions, and we're able to work across the board with these platform partners to integrate and support fraud detection for different type of faster payments that's in practice. So in closing, we kind of set a stage of what are the key components that are necessary for faster payment fraud, and what type of capability you would need in order to fight the fraudster, exploiting your faster payments. So in the example we illustrated, we hope that we have made the impression that we're ready to help our financial institutions to combat these new type of, financial fraud or financial crime as the fraudster adopt faster payments too. But regardless of what financial detection service you choose, we want to remind you that there's 3 key things that ensure a secure and frictionless faster payment experience. Number 1 is you need to have a real-time detection. Number 2, you should utilize machine learning and behavioral analytics to reduce your false positives and adapt as they learn to any new emerging fraud scheme. And lastly, but not the least, is adopt the real-time risk-based intervention so you can move your fraud operation from loss recovery mode to loss prevention mode. And with that, I'm going to hand it back to Eric.
Okay, thank you, Wendy. So if you want to learn more, these are URL that we put in the PDF, but so that you can easily type it. Guardian Analytics has a wide range of products from digital banking, mobile and online business fraud detection to ACH and wire fraud detection and fraud detection analytics, as well as AML, money laundering with Evidence Lake. Now, in regard to faster payment, we have a series of webinars, but one of which that we do recommend you to watch is how to prevent peer-to-peer payment fraud in real time, where IT Research Group has partnered with us to explain the P2P ecosystem. This is where you basically going to see a better explanation of participant services in a P2P environment. And of course, we have a Bright Talk channel for you to watch all those videos. With that, we will open the Q&A session. So just before, I'm seeing 1 or 2 participants that has technical issue, either loading the page or listening. Please ensure to send us an email, and we're going to ensure that you will receive the video and the deck so that you don't miss this webinar. Otherwise, I have a couple of questions. So the first question is, does real-time intervention work for ACH? Wendy, you want to take that one?
Sure. So the answer is yes. The intervention works for ACH. It's a slightly different mechanism compared to, API-based real-time data integration. The intervention is sent back to the ACH platform in a near real-time fashion with batch files. This is designed due to the nature that ACH is itself being a batch process, so the data usually is sent to fraud detection platform in batch, and therefore we applied the intervention in batch back to the payment platform. But we try to make it near real time, so as soon as possible. But because ACH itself is kind of giving the fraud analyst a window already to review and making decisions on those fraud alerts being triggered, we try to give the answer back to them, but working with this batch process with the payment platform.
Okay, thank you, Wendy. We have another question, Wendy. Do fraud analysts need to review transaction immediately and return a decision while customer is at the point of sale? So this is interesting.
Yeah, so I think this is where automated risk-based intervention comes into play. I mean, is it possible for a fraud analyst to review the transaction and then make a decision? I think it's possible, but is it scalable? And then whether it can be done in a timely fashion is the question, right? So because, you know, depending on the timing when the fraud analyst receiving the suspicious transaction and how long it takes to collect data, making a decision, reply back, there is a impact on the point of sale side for that customer who is waiting for their transaction to be either approved or rejected. So this is where machine comes into play, where the data analysis and monitoring and decision making can all be done in like a millisecond speed, and the intervention can go back making the appropriate decision. And then the fraud analyst review could come as a second leg of it, depending the risk level or characteristics of the suspicious transaction.
Yeah, actually, we've been discussing with banks that try to implement, faster payment fraud detection, and again, it goes back to what we call friction right detection. I think we believe it's a necessary capability. In other words, if you trust the behavior analytics and machine learning, it will raise the risk score in real time according to the suspiciousness of the logging activity, be they first time or ongoing. But then when it's really risky, at that point you will trigger a progressive friction. In other words, you could possibly see a mobile device with a user coming in and watching the stops, and at that point he may be a fraudster, but you're not going to ask for any password. But then he wants to do wire transfer or do any kind of banking activity. At that point, the multi-factor authentication will start to say, well, give me your passcode, your fingerprint, or whatever. We do believe that the balancing of friction authentication is the answer to real-time fraud detection at point of sale, at point of presence. Okay, we do have a lot of questions coming in. One is, how long must an end-user activity behavior be observed for Guardian Analytics to be at its most useful? So it's about machine learning. So it all depends on the type of payment. So if you look at wire, ACH, or digital banking, in the case of online and mobile, when Wendy has described to you the circles, we have models adapted to payment channels first, so either wire, ACH, or the FI or the FI. But for the digital banking side, so let's say mobile devices and online, for example, we have specific models for mobile devices fingerprinting. So at that point, if it's at the interaction of digital banking, it's in real time. I mean, we look at everything, activity, location, mobile devices, and we have hundreds of indicators there. So it doesn't need to learn. I mean, any deviation out of the norm will be flagged. But more importantly, it combines the payment activity with the login, logout activity. So in other words, if for whatever reason there's an account takeover, as you can see, 700 million leaked users and password, you may as well say, well, he breached that. You can't identify it's the user. Well, still, because if he's doing a payment and a wire where the recipient start to change, we will flag it. And that is, for the machine to learn that, it all depends on the wire data set that we've been given. Um, what are the SLA for real-time fraud score response times for your system? That's the first question. And when will Zelle real-time fraud detection be available to your existing fraud detection real-time client? Wendy, you want to take that one?
Sure, I can speak to those questions.
Yeah.
So for real-time fraud score response time back to the digital banking or payment platform, the response time usually is in milliseconds. That's what we say. That's truly a real time, right? So it's at the machine level response, and not at the human level response. For Zelle real-time fraud detection, we're actually working with some of the customers who are implementing Zelle for their banking product and services, and we're working with them to figure out the right architecture, data architecture should be. The Zelle fraud detection depends on who's going to send us the data. If the data is being sent as part of their digital banking data feed, then we can evaluate it in the Zelle fraud risk as part of or in context of the online banking or mobile banking user behavior. There's also other possibility where maybe your Zelle provider is going to send the data as a standalone feed over to Guardian Analytics, and then we will basically engage and calibrate a model for just the P2P data feed. So I think it also depending on at what phase that you're engaging with your Zelle vendor to implement that as part of your digital banking product and services. So it's kind of like case-by-case variation, because different customer today has a different approach and also timeline for implementing Zelle. So if you're interested, you're planning to implement Zelle in your digital banking product, please let us know. We're very happy to work with you to figure out what's the best architecture for you, and then how we can engage with you tailored to your specific needs.
Okay, thank you, Wendy. I have another question. How to start before machine learning detects not good behavior? So this is a very good question, because machine learning, you need to learn before you can detect. So the question is, if you don't have good behavior, how you can go and feed the machine? Well, in the case of Guardian Analytics, and again, you have to peel the onions like on those various circles. We have models that are totally being tested, because we have a portfolio of hundreds of customers that are doing mobile, online banking, ACH, ODFI, RDFI, and wire. So at the start, we already have a model that catches most of the suspicious activities, both in digital banking and in payment channels. Yeah. So the machine is being bootstrapped, if you wish. But then it starts to learn by its own. This is very important, because in the case of machine learning, there's basically two types of methods. One is unsupervised, which is our case, and one is supervised. The supervised requires that you feed the system with a known data set of good behavior. In our case, this is not it, because we already have all the models over the years, both from digital banking side and payment channel. In the case of Zelle, our assumptions right now is it's going to behave pretty much like digital banking. But if it starts to drift, then at that point, the system is going to automatically learn the deviation. This is the big difference amongst machine learning engine, right? You have to pick the right one to be sure that it doesn't doesn't necessitate for you to feed the system with a known set of fraud. We have room for probably 2 or 3 more questions before the end of the webinar. So I'm going to select one, and the others we will answer them by email. What type of fraud caused the fraud rate to triple in UK? So our understanding, when you read UK in 2008 and between 2000 and 2010, the first 2 years, it was mostly authentication, so account takeover. They implemented back in 2011 and 12 more multi-factor authentication, but it was really full friction. So it went down. But again, if you read the news, they start to be under more sophisticated attack right now that necessitate, that pass by multi-factor authentication because of account takeover. So it's resuming per se, and that's why they are implementing new technologies such as machine learning. And let me see, last question. One of the indicators you say you monitor is IP location. Many IPs these days are from cloud providers such as AWS. How do you deal with that? Wendy, you want to take that one?
Sure. So it's very true that the geolocation signals can be diluted by cloud providers, aggregated IP, or changing DNS. So in such events, the risk signal from the IP is weakened, and our risk model will learn to rely on other signals to identify anomalous account behaviors. So IP is just one of the many risk indicator contributors when the model evaluates overall risk. So it will learn to adjust the, dependency on these risk signals. If it detects a one-off, IP no longer provides, is no longer a strong signal, then the behavior or the model would adjust its evaluation and rely on more other signals.
Thank you, Wendy. So we're coming at the top of the hour of this webinar. If we didn't address any of your questions, please email at success@guardianix.com and we will address them by email. We're going to ensure that we have the right answer for you. So thank you very much, and looking forward for the next webinar with your participation. Thank you.